Okay, here we have the example number 1 for the general plane motion, where we have a uniform 60 kg slender bar, which initially at rest on a smooth horizontal plane. Okay, when uh, when the force are applied. Okay, here we need to determine the acceleration of the bar mass center. Okay, normally we are referring at as a point G, and also the angular acceleration of the bar at this instance. So the alpha for this particular bar. Okay, to begin with, we start by calculating the mass moment of inertia of the bar. Here we use the definition, the general formula for the bar, which is 1/12 ml square. M, as we know, it is 60 here, and then 3 is the whole length of this particular for this particular bar. Okay, from this point to this point. Then we just calculate. Then we got the I at point G, which is 45 kg meter square. Okay, next, we calculate the summation of forces in the y direction. Okay, if you notice in this particular example, we don't have any support structure or wheels to support the weight of this particular bar, and also there is no forces involved in the x direction, okay, in the horizontal direction. Okay, now we are looking at the going up is our positive direction for the y, and here we have 80 minus 20. Okay, 80 is pointing upwards. Okay, let's say this is our coordinate system. So y, x. Of course, we don't have any forces involved in the x direction. We're only interested in the y. And going up is our positive direction. Here we have a positive, and here we have a, because going down we put it as a negative. And then again, m is given here, 60, and ag is the one that we want to determine. Okay, and simply rearrange or solve this particular equation, then you will get, okay, the acceleration of the bar mass center is 1 meter per second square going up. Okay, now move to another part where here we want to calculate the angular acceleration of the bar at this particular instant. Okay, counterclockwise is our positive direction. We assume it like that. And okay, now we want to calculate the angular acceleration, where we look into the moment at point G. Okay, point G is somewhere along this bar. Okay, and then 80 times 1 meter. Okay, times 1 meter plus 20 times 0.75. Okay, since here, if you notice, we have the word uniform. What does it mean is the weight of this particular bar is uniform. Okay, when we have a uniform weight, that means the weight is acting at the center, okay, of this particular bar, slender bar, and therefore point G is in the middle here. Okay, point G is in the middle, and from this to that one, okay, is equal to 0.25 sorry, this one should be 0.75, okay, because it should be in the middle. Okay, because here you have 0.75, it should be 0.75 plus 0.75, okay, to get 1.5, because the total length here is 3 meter. Okay, so half of it should be 1.5 meter here, 1.5 meter on this side. Okay, so this is the thing. And then on this part, it should be 1 meter. Okay, because 1.75 minus 0.75, so you're left with 1 meter. So now, for this particular force, this is our center of rotation. It will make a counterclockwise, so it is a positive times 1, okay, the parallel distance from the forces to the center of mass or point G here, and then plus, because these particular forces will create another counterclockwise motion as well, same direction, okay, and then multiply by the perpendicular distance here, which is 0.75 meter, and that is equal to 45 alpha. 45 is from here, okay, the IG, and alpha is the one that we are interested. Then solve this particular equation, because we only have one equation and one unknown. Therefore, alpha is equal to, or the angular acceleration of the bar is equal to 2.11 radian per second square. Okay, thank you.